times. Please allow me to introduce myself. My name is Guillermo Loaiza. I am a PCS protective coatings specialist, and I also have an MBA with a major in quality assurance systems. I lead the SSPC and ACI Ecuadorian chapters as their current president. I'm also leading as president for SSPC Latin American Advisory Council, and I'm also an active member of the International Concrete Repair Institute. Currently, I am the CEO for Setmix Products, company doing business in Ecuador, Peru, Panama, and Bolivia. I'm sharing you here my contact information in case you need to get in touch with me and ask any further questions. Setmix Products is a company with over 20 years of experience offering comprehensive solutions for mixing, repairing, reinforcing, and protective coatings for concrete. For over 20 years, Setmix Products has been offering a set of technical solutions for all stages of concrete development. Let's see here. We offer a product line that goes from products added to fresh concrete, such as admixtures, synthetic fibers, to products for repair, reinforcement, and protection of concrete structures. Well, now on the purpose of this webinar. What I want to do is share with you what we have done to keep doing business under the COVID-19 crisis and how we established the necessary knowledge to set the strategies and then reactivate our company operations when the quarantine ends. What is COVID-19? Is this infamous virus affecting us all under this pandemic? We already know it is a respiratory disease that has all the world under a health and financial crisis. Even though this virus is closer to get under control, we need to keep ourselves aware that 1 of 5 people infected with COVID-19 shows severe symptoms. And when this COVID emergency was initially reported and the world had to deal with it, at that point we didn't really know how to deal with it, how really deadly it really was. The situation forced every government around the world to get under quarantine and halt all activities and stop spreading the virus. Our company, like most others, was right there with the stores closed, hoping to one day sooner than later get back to business once again. Ecuador got quarantined in the early days of March, and those first following months, we didn't have the full scope of the situation. We didn't know when we were going to get back to our activities or if we were going to be healthy enough to do it. In this chart, you can see how quarantine really began in March and moved forward all the way to June. We can see data showing us that at least 80% of companies were not operational nor operating well under their normal capacity. Construction and service industries are the most affected sectors, especially those with less than 200 employees. This meant to us that too many businesses were dangerously at risk of closing down, and we needed to take action to adapt and to survive. Sales plummeted to under 40% for at least over half of the still active companies. And projections forecast that it would have taken around 4 months for companies to reestablish some ground and finally return to a usual level of activities. It is clear now that we are around December that this situation, this crisis, still prevails and will continue like it for at least another 5 to 6 months ahead. Once our government authorized some industry sectors to progressively reopen their activities under strict sanitary protocols, the construction sector was the first to be set in line for reactivation when it began in July. With this, we began to think what to do now. How are we going to achieve the objective on how to reactivate ourselves and maintain some level of operations under this situation? Data was showing us that most companies didn't want to consider closing down as an option, and so do we. Critical measures were needed to be implemented, combined with some administrative decisions based on government's limitations. Once again, data showed us that we needed to be resilient, adapting to the situation, redesigning ourselves, and in that way we might be able to resist this crisis. So, as needed skills, we can see that resilience, creativity, emotional intelligence, innovation, and flexibility are the top skills needed, followed next by digital media use, effectiveness, leadership, and empathy. It might catch your attention to see that leadership is at the bottom of this list, and I think that the reason why is that leadership already is a well pre-established requisite requirement that any and all company needs to survive. To reactivate our operations, we needed to find a customer base that wasn't affected or at least less affected than the others. Only 6% of registered companies showed an increment in their operations, most of them being pharmaceutical. And next to pharmaceutical, important food and beverage companies were having some sustained operations and are the next in line adapting and implementing their processes and facilities to meet with requirements under the current situation. Right here, we have a good look at what these industries might expect of properly protective concrete surfaces. All things considered, we at Setmix decided that the right approach might be to get to these industries and offer them protective coating systems that, when acquired, might lead to other needs such as concrete repair and concrete reinforcement. Reasons for concrete protection we have as follows: protective lining or barrier coatings against chemical and mechanical deterioration, waterproofing, damp proofing, and freeze-thaw cycle protection, enhancing surface functionality, reflectivity, aesthetics, and thermal resistance or improved reflective properties. As expected, once we offer the owner some concrete protection systems, the need to do some concrete repair and or reinforcement usually comes along. As you can see, when we final apply coatings as shown here, there's usually also the need to do some previous repairs and in some cases, some reinforcement too. One important thing to get this strategy started and running was to always reflect on our clients that we are consciously minded to follow safety protocols and keep everybody safe, healthy, and free of a COVID infection. We then resumed our activities right after finishing complete our requirements on training for our personnel on COVID safety protocols. We need to wear masks, wash our hands, avoid touching others, and avoid touching your own face. To keep distance that are recommended 2 meters away should always be followed. It was then that projects did finally begin as shown here at these client facilities. Going through surface preparation, priming, rippers, joints, surfacing, and finally, top coat application. In this chart here, we can follow how to meet all honor requirements on structure protection, ease of maintenance, aesthetics, and durability. All these achieved following guides and standards set by organizations such as SSPC and ACI on what is specified and properly installed. Here is a list of some guides and standards that should be followed during the installation of protective coatings at any project and achieve best results. Finally, keep in mind that there are two types of base projects to specify as a starting point. One is for new construction projects and the other for repair and maintenance of existing projects. To conclude, adequate system selection for concrete protection, as specified, shall be achieved by meeting technical requirements based on use, environment, and durability. The specification shall be created and designed by an experienced certified professional in coatings protection, and technical criteria shall always prevail over any sales point of view. Very important. All of these should be achieved following protocols and safety requirements under COVID-19 times. Thank you for being part of this webinar presentation.
a structural engineer from the Faculty of Civil Engineering of the University of Buenos Aires. First of all, I want to thank CADC for the kind invitation to give a conference at this important event. The English language is not my native language. I will try to do my best to be able to give a useful conference. The title of the conference is Construction Process of Precast Elevate Viaducts and Bridges as a Response to Speed Up the Evolution of the Construction Industry due to the pandemic. I will briefly provide concepts about the design and construction of bridges for rail and road uses. Finally, I will provide conclusions and opinions on how to improve the construction practices of these structures, especially the use of the ABC construction method to face the new challenges that emerge in the post-COVID era. Structural design. Having elected the construction of an elevated viaduct from another alternatives, the structural design and construction are mainly determined by advantages and disadvantages between casting place versus prefabricated construction, casting yard availability, transport difficulties, width of the deck, roadway or railway geometry, accessibility of direction equipment, placement of the project, rural, urban, or mountainous zone. Piers and foundations. Piers, in general, rectangular or circular RC concrete columns, bents, RC or PT concrete caps, and two or more columns. Shallow foundations or group of piles, closed or open abutments. Decks. Construction method. Between 30 meters up to 50 meters span length, precast systems, and between 70 meters up to 300 meters casting plate methods. Static systems, continuous or simply supported. Main erection systems, full span, span by span, balanced cantilever, incremental launching, and progressive placement. Main connect sections, U-girders, box girders, multiply I or U beams, plus casting place or prefabricated deck slabs. Section depth, constant between 30 meters up to 60 meters span length, and variable between 70 meters up to 300 meters. Erection equipment, launching gantries, cranes, movable scaffolding, lifting frames, for travelers, and launching shacks. Precast systems, segmental span by span and balanced cantilever by launching gantries, lifting frames, or cranes. Full span by launching gantries, incremental launching by launching jacks and steel noses, U or I beams by girder shifters, and cast-in-place systems, segmental balanced cantilever by formed travelers, and full span by mobile scaffolding. Economical span length ranges, concrete bridges. Slab or T up to 20 meters span length. A girders between 20 meters up to 50 meters. Incremental launching between 30 meters up to 60 meters. Span by span system between 30 meters up to 50 meters. Balanced cantilever precast system between 40 meters up to 110 meters. And cast in place system between 70 meters up to 300 meters. Usual cross sections. Unicellular box girder, U-girder in segments, U-beam plus cast in place or precast deck panels, and mixed concrete steel box girders plus cast in place slab or deck panels. Composite action, single or double composite action. Less usual cross sections, multicellular concrete box girders, all of this. When the width of the bridge is necessary to be high. PT concrete box girded with corrugate or trusses steel webs. Concrete, the upper slab, concrete, the bottom slab, and webs with corrugated steel or trusses. Optimum span ranges for different cross sections for railway viaducts. Ratios between span length and depth of the cross section. Slabs, concrete box girders, mixed girders, steel sections, and simple or double mix actions. Cast in place concrete deck or prefabricated concrete deck, U-beams, and prefabricated decks or cast in place decks. Some important details: balanced cantilever and continuity PT, shear keys, bottom continuity tendons, cantilever tendons, bottom PT bars, all of this for the cantilever system. Span by span with external or mixed PT, mixed PT, external PT for simple support or continuous systems. And then transverse PT in deck slabs, diaphragms, webs, and deviators. These are the main construction details for balanced cantilever and span by span systems. Construction, cast in place versus prefabrication. Precast cement erection, balanced cantilever erection with launching gantries, span by span erection with launching gantry, balanced cantilever erection with lifting frames, balanced cantilever erection with cranes, precast beam method, full span precast method, span by span erection on false works, and in situ construction, incremental launching, and form traveler method. Precast segments. launching gantry. Span by span with launching gantries, span length between 30 meters up to 50 meters. Balanced cantilever with launching gantries. Segments, balanced cantilever, launching gantry, span length between 40 meters up to 110 meters. Incremental launching between launching jacks and steel nose. Span length between 30 meters up to 60 meters. And progressive placement of segments with cable stay system or temporary piers. All of them are segmental systems. Precast full span with launching gantries. Span length between 20 meters up to 50 meters. U-girders, box girders. Cast in place segmental with form travelers, usually used in balanced cantilever method, between 70 meters up to 300 meters span length. Cast in place, full span, with movable scaffolding system, this machine. This overhead girder holds the scaffolding system between 20 meters up to 70 meters span length. Single beams, precast single beams, A and U, with girder shifter, the girder, and then casting plate slabs or precast deck panels between 20 meters up to 50 meters span length. This girder can shift the beams. Construction cycles, main aeration methods. It is very important to estimate the construction cycle of a single span in order to determine the needs of the storage yard, precast construction buildings, and number of molds. Construction facilities and equipment. Precasting yard, segment transporter between the precasting yard to the bridge, to the placement of the bridge, precast construction building, segment and molds, and lifting frames to transport segments into the precasting yard. All of these are construction facilities and equipments. Full span molds, U section, and box girder section. Long line and short line precast method. Construction system by conjugated segments that ensure correct fitting in straight or curved spans during the erection. Main erection equipment. Launching gantry for span by span. Launching gantry for full span. Cast in place full span with movable scaffolding. Cast in place segmental with form travelers. And incremental launching with launching jacks and steel noses. These are the main erection equipment and systems. Accelerated bridge construction. Based in prefabricated bridge elements and systems. Easy transport and fast erection. Improve in place construction, total construction time, and public security. And reduce traffic perturbation, in place construction time, and climatic issues. This method, in my opinion, is very important for the post-COVID area. Prefabricate foundations, prefabricate columns, prefabricate segmental columns, bend caps, walls for abutments, caps for abutments, in place connections. All of these are prefabricated bridge elements that should be connected by in place. Seismic PV connections, energy dissipating connections, ultra high performance concrete, super elastic shape memory alloy, and self-centered columns in order to achieve the performance-based damage states. In place connections, mechanical bar connections, growth ducts, pocket connections, socket connections, and two-stage integral pier cap. All of these are in place connections of the PVs. And finally, precast decks. Full or partial depth concrete panels connected to PT concrete or steel beams. Well, now I want to show you two viaducts constructed in Buenos Aires. The first one is called Mitre. It is a 4-kilometer length viaduct. The erection system was span by span. It's a railway viaduct. The section is a box girder, a concrete box girder with external and mixed PT. Here you can see a segment, a mold, the casting yard and the segments storage, the launching gantry, and the construction finished. The second one is a 5-kilometer viaduct in Buenos Aires too. It's a railway viaduct too. is called San Martin. In this case, the direction system was full span. It is a concrete bus girder with internal PT. Here you can see the self gantry, launching gantry, and the self-propelled transporter. And this is the construction finished. Improving construction practices, processes, and guidelines in post-COVID world. Conclusions and opinions. New bridge and viaduct constructions and retrofitting of existing structures are highly relevant activities in public works all around the world. In many countries, the public work construction industry can quickly help to reactivate their economies. To achieve this objective, the sources of financing through multilateral credit and development banks, fundamentally in development countries, is a crucial issue. These important infrastructure projects employ a large number of people, project, production, and management, architects and engineers, suppliers, construction workers, administrative staff, etc. The ABC method of bridge construction can be a valuable tool in safety and overall care within the construction industry. Prefabrication is prone to further organization, planning, and control of all types of activity relate to the industry and particularly with the mitigation process of this problem. In addition, the work in place in systematized processes, basically of transplantation and assembly of precast elements, are also prone to being able to comply with the OSHA recommendations. These systematized construction processes, in general, have greater facility in visibility and financing analysis along with the compliance of the budget with limited deviations. This premise can mitigate the great risks and challenges posed by the post-COVID era. Maintenance and management of workforces, human resources, financial sources and financial health of the construction companies, recovery and stabilization of the supply chain, improvement of safety and overall care within workplaces. Well, thank you very much for your attention. I would like to thank CADC again for the invitation to give this lecture. It was an honor and a pleasure for me to have done it. I also want to thank the assistants for their kind attention, hoping you have found the conference interesting. Best regards to all Indian people and goodbye.
from a very sunny Belfast. It's a lovely winter morning here. My name is Sri Nanakutan. I live and work in Northern Ireland. I work at Queen's University Belfast, where I'm a lecturer and a researcher. This talk particularly is about innovation and how innovation has been used to embed resilience in the concrete industry. So I'm going to call it a Northern Ireland model. And I'll take you through some of the previous economic downturns and how the companies managed to come out of the recession using different products that they released. Some of my colleagues are helping me with this talk, and they've given information for the talk. So it's Dr. Daniel McPolin, who did a lot of work on FlexiArch, and Professor Adrian Long, who invented the arching action and FlexiArch. You will see that in a minute. Mr. Abhay Gupta is a good friend, and he works in Macrete, and he controls the production in Macrete. And Ruben is his counterpart in Crea Concrete, and Ruben gave all the information about Rapid Res, which you will see in a minute. So first, you need to know how the Northern Ireland concrete industry works and what is it made up of. Okay. So
everyone, my name is Fernanda Pacheco. First of all, I would like to say that I'm grateful to be part of this event. I work at an university in the southeast part of Brazil, which is named Unicinos, and it's part of a global network of universities, which is Jesuit University. I'm here to present the work that is self-healing and self-repairing concrete. We know that concrete has a huge use worldwide, and the cracking is a pathological damage that may lead to severe deterioration. So there's a need to increase the durability so we can save money, we don't need to do reworks, and also that we can turn structures to be sustainable. Studies of mechanisms that can act on concrete, creating products that can heal the cracks, lead us to the knowledge of self-healing and self-repairing concrete. They are divided because self-healing is considered for healing as any process carried out by the material itself that involves the recovery and improvement in the performance of material that has been damaged by any process previously. And self-repairing, it's limited to the closure of the crack, and it doesn't involve properties as physical or mechanical. We have self-healing mechanism that is autogenic or autonomous. From autogenic, we have materials that it's already used by concrete as cement or pozzolanic materials. And for autonomous, we put some material in concrete only to have this healing capability as chemical compounds of bio solutions, for example. So this classification is based on the materials needed for the process. We know that mechanisms they have requirements to occur. There's a need to evaluate if they can work on real structure or real exposure conditions. We know that there's an influence of curing condition, and it's also need the analysis of the reliability and also if the mechanism can work in multiple cracking. And different mechanisms, they have different maximum thickness, which they can work in. Self-healing mechanism, we have autogenic by cement consumption. We have two options. There is hydration of non-hydrated cement particles and dissolution and carbonation of calcium hydroxide. This is a mechanism that is influenced by water, the crack age, the crack width, and cement consumption. We have also the autogenic by the use of pozzolans. They react with calcium hydroxide and water, and they promote the CSH. This is related with cracking on early ages when we still have the pozzolanic reactions to occur. We can also have the autonomous bibacterial solution. It works similarly as the human body healing, as blood clotting and bone recovery. And related to the bacterial solution, it's the process that occur usually is the carbonation of CH and the reaction with bacterial solution. We have to choose the bacteria, and in Brazil we have the Bacillus subtilis AP91 that is proved that can produce carbonate, so they can be used for concrete biocementation. We also have the option to use chemical solution that is usually commercialized ready for use as sodium silicate. It also reacts with cement compounds and can also promote the CSH. To use bacterial solutions and chemical solutions, we have the option to use capsules to put these materials as expanded clay or expanded perlite. This study, they compare those two aggregates, and they discovered that perlite works well for the healing, for example. We also have the option to use or not the vacuum chamber to put the materials inside those capsules. Some authors pointed conditions related to environmental, where this structure is inside and the cure. So in et al, they pointed out that marine environment works well for the healing. Palin, Victor, and Jonkers, they cure samples on marine water and potable water, and they discovered that marine water works better. Related to carbon dioxide, we have the carbonation reduces the pH, which is better for the bacterial survivor. Udry and other authors, they aged ACC for 1 year, and they also discovered that this carbon dioxide works better for the cure condition. Hoig Flores, they say that there is a need of water, and Luo, Kian, and Lee, they say that wet condition is better than wet and dry, which is better than only humid condition. We have procedures for concrete cracking, as put materials on the fresh state, put the samples on the stove to the cracking formation by heat, to cut the samples, or do the deflection test. And also to check if the healing and the repairing is working, we have chemical, physical, and images analysis. What we learned in my research group here in Brazil, first of all, we were also comparing expanded clay and expanded perlite from Brazil, and we checked by the same analysis that expanded perlite has much more voids, so it may be good to put the chemical and bio solution, and also that there's a higher impact when we use expanded clay than expanded perlite, so expanded perlite may be better to not damage the concrete properties. And also by analysis, by view analysis on microscopy, we check it out that expanded perlite, it's better to conduce the continuous healing inside the crack. We have to choose the bacteria, and also we have to obtain the bacteria development curve, so we can choose the solution that we are using in every sample. We know that there's an influence of bacterial solution on the capability of to produce calcium carbonate, for example. So we check the solutions with concentration of 6, 7, and 8 UFSC for ml. And we check that with solution of 6 that we have progressive behavior, and it was able to heal the cracks of 0.46 millimeters. We have solution of 7. The product was only formed on the crack perimeter and with values of 0.22. And with solution of 8, we check that the product was inside the crack and on the surface with the maximum value of 0.19. There's different mechanisms. We have environmental impact and we have healing capability to be analyzed. So we did a experimental procedure, a huge experimental procedure, and we were analyzing the semen consumption, for example, and it was able to promote the continuous healing with crack of 0.59 millimeters. We also evaluated superficial irregularity. It was good to form the product made because of the presence of water, continuous presence of water, and the size was 1.2 millimeters, which is really good for being above 1 millimeter. There it's usually what we have in biography. And we did the XRD analysis, and we checked that there's CaSH, CSH, and calcium carbonate. Also, the shape is okay with what were expected. With pozzolanic materials, we checked that the product was mainly formed only on the cracking perimeter, with which was the width of usually 1 millimeter. We have samples with 7.5% of silica fume and 15% of silica fume replacing cement, and we check also the crystals that are forming on the crack perimeter. and we see this almost the same materials from the other mechanism, and we have those products as layers from the same analysis. Using sodium silicate, we saw the crystal shape, and also we saw a solid material on the crack. We have 1.48 millimeters, which is really good. And we also have some cracks when it was not completely recovered. And here we have those different shapes of healing with 0.44 and 0.42 millimeters. And also the chemical analysis that is showing like calcium carbonate and silicon oxide, and here the shapes from SEM analysis. From bacterial solutions, we have the crack completely healed with 1.67 millimeters, and we also have here inside the crack here as continuous healing from small cracking and bigger cracking, and here inside the crack here there's a solid material in all the continuous crack. And here there's a common occurrence that material is not only inside the crack, but also on the surface of the samples. Also, we can check those phenomena. And here we find out calcium carbonate, silicon oxide, CSH, and organic materia. When we check the medium values for crack repair, we may think that semen consumption was the best option, which is not, because there's just a few occurrences. Then that's why the medium value is bigger than in the others. We can see the good behavior from chemical and bacterial solution. And for the maximum values, we reach the values above 1.6 millimeters for bacterial solution, which is really good considering the real crack in structures. This is the data that we obtained in this research, and I will be glad to share it with you if you have interest. And to finalize, we analyze the pure condition, and we check that submerged is better than only wet for semen, pozzolanic, chemical, and biological solutions. So maybe a condition for self-healing to occur. And I appreciate your time. Here is the social media from my university and undergraduation course, and here you have my mail. So I will be glad if you contact me asking for more details of this research. Thank you again for the invitation. I hope we all have a good event.
Above the world so high, and down on the ground, the advancements that you see in India's aviation, the success saga of the excellence shown by Airports Authority of India. AAI is constructing, operating and maintaining world-class airports. Along with that, AAI has a site that's down to earth and close to the people. That's clearly visible in its CSR programs and activities. Through its CSR activities, AAI has keenly focused on skill development to generate livelihood opportunities in remote areas. AAI has tied up with construction industry development council for skill development of unemployed people belonging to economically weaker sections.
in construction industry there is a huge shortage of manpower. At the same time there is unemployed youth. So if we provide them, it will be a win-win situation for both.
Through this skill development training, the student get theoretical knowledge and practical knowledge in construction-related land survey, like electrical wireman, general work supervisor, site accountant, and storekeeper, etc.
Actually, here we are providing training to the unskilled youth who are unemployed. We distribute pamphlets at the different locations of UP, Bihar, West Bengal, unskilled manpower. We can make them skilled. So we are providing them 3 months
More than 5,000 students have been trained skill development training program since 2015.
जब मैं यहाँ पे आया था तो इस सब्जेक्ट से रिलेटेड ज़्यादा नॉलेज नहीं थी, लेकिन यहाँ आने के बाद इस फील्ड में मुझे काफ़ी नॉलेज मिली।
2 महीने हो गए ट्रेनिंग के, 1 महीना बाकी रहा और 1 महीना बाकी रहा, कुछ सीख लिया 2 महीने।
यहाँ से मतलब सीख के जाएंगे, हम दुकान सीख के जाएंगे, हम दुकान अपने घर पे जाके अपना कोई बिजनेस।
ये बहुत अच्छी दे रहा है एयरपोर्ट और जिससे कि बच्चे अपना आगे का फ्यूचर बना सकें।
With this skill development training, AI has generated employment for many of underprivileged and uneducated youth. And on the other side, AI and other PSUs got a skilled worker for their construction sites.
से हमको ट्रेनिंग से लाभ हुआ है। मैं आज यहाँ पे जॉब पे हूँ, यहाँ पे जो है मेरा काम यहाँ पे जो है कुछ लाने का मतलब जो बाहर से ऑर्डर आता है मैं डिस्पैच स्लिप से यहाँ से बना के माल बनाने मतलब माल को बनवा के साइट पे भेजना होता है।
पहले मुझे कंप्यूटर की बिल्कुल भी नॉलेज नहीं। धीरे मैं 3 महीने में इतना सीख गई। वो लोग मेरा कॉन्फिडेंट यहाँ पे एम्प्लॉय रख लिए।
Our motto by doing all CSR activities Authority of India is to make the difference and feel that.
Airports Authority of India has come to lend distinct prominence to India on global aviation map. Share this pride with every Indian. We shall continue to serve them and enrich lives of everywhere. Above the world so high and down on the grounds, the advancements that you see in India's aviation is the success saga of the excellence shown by Airports Authority of India. AAI is constructing, operating and maintaining world-class airports. Along with that, AAI has a side that's down to earth and close to the people. One that's clearly visible in its CSR programs and activities. Through its CSR activities, AAI has keenly focused on skill development to generate livelihood opportunities in backward and remote areas. AAI has tied up with Construction Industry Development Council for skill development of unemployed youth and people belonging to economically weaker sections.
In construction industry there is a huge shortage of skilled manpower. At the same time there is a unemployed youth. So if we provide
लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीजों का लेवलिंग लिया जाता है।
The student gets theoretical knowledge and practical knowledge in construction-related subjects like land survey, electrical wireman, general work supervisor, site accountant, and storekeeper, etc.
I belong from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. There is not sufficient. I heard about my son training.
More than 5,000 students have been trained for this skill development training program since 2015.
I learned about foundation, cement, chain, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
2 महीने हो गए ट्रेनिंग में बेरोजगार था तो मेरा दोस्त क्लास में पढ़ता
From a very sunny Belfast. It's a lovely winter morning here. My name is Sri Nanakutan. I live and work in Northern Ireland. I work at Queen's University Belfast, where I'm a lecturer and a researcher. This talk particularly is about innovation and how innovation has been used to embed resilience in the concrete industry. So I'm going to call it a Northern Ireland model. And I'll take you through some of the previous economic downturns and how the companies managed to come out of the recession using different products that they released. Some of my colleagues are helping me with this talk, and they've given information for the talk. So it's Dr. Daniel McPolin, who did a lot of work on FlexiArch, and Professor Adrian Long, who invented the arching action and FlexiArch. You'll see that in a minute. Mr. Abhay Gupta is a good friend, and he works in Macrete, and he controls the production in Macrete. And Ruben is his counterpart in Crea Concrete. And Ruben gave all the information about Rapid Res, which you will see in a minute. So first, you need to know how the Northern Ireland concrete industry works and what is it made up of. Okay, so our concrete industry is about £2.4 billion worth to Northern Ireland. So it's a large part of our commercial income. About 50% of the UK precast production happens in this region. It's made here and then it's transported to mainland UK, shipped to mainland UK, because we're an island. So you can imagine how that economy worked, large concrete pieces going in the ship across to the mainland UK. That's achievable because of the low transportation cost from here to mainland. And that's not a long-term phenomenon, but that's been there for the last 15 to 20 years. So therefore, we benefited from that greatly. But the biggest part of that, and the biggest part of how our companies were able to capture the market in big market in GB, is because of the following reasons. We have fantastic skilled labourers. We have plenty of water, quite the rainy part of the country, and good quality aggregate and really good supply sources for the minerals that we need, cement and whatever that may be. So that all of that makes up, with big production facilities, we were able to produce audacious products, really big products that are challenging otherwise to make, and then ship them across at a competitive rate. On the right-hand side, you'll see the logo of some of the big companies in Northern Ireland who became bigger during this time period and sustained that growth to a point that they're probably the top companies in the UK as well. The supply market works this way, that our largest market is GB, as well as we supply to the rest of Ireland from here, which is through roads, quite easy to do. Okay, so that is our concrete industry in a nutshell. Looking at the vulnerabilities of this industry during COVID, okay, this is work done by my colleagues at Ulster University and the economics team. So on the figure that you see on the right-hand side, you will see the financial resilience on the y-axis and the degree at which they will be affected by COVID is on the x-axis. Manufacturing, construction, two of the sectors that concrete industry will be in, are in this spectrum here. So because of the large overheads, mostly on equipment and skills and products, manufacturing would be considered as less affected. Because yes, the people will be affected, but the products and facilities are already there. They can go back and sell it as the market bounce back. Construction, on the other hand, is a lot more people oriented. So that will be more affected and they will have less reserves, financial reserves in their hand. So that gives you an idea why resilience is so important. And also give you an idea of how the COVID related effects, that will be either an economic effect or employment and economic effect. We'll look at the figures in a minute. So how would this impact? First thing, you need to look at the previous recessions. So 1980s or 90s, these were mostly economic as well as employment impact, largely employment impact. So unemployment would have been the biggest issue. 2008 recession was slightly different. Employment was affected, but GDP was a lot more affected. They are suggesting, the Ulster University's team are suggesting COVID for Northern Ireland will be both a financial impact as well as an economic impact. And that's quite hard to swing out of. It's not an easy task to get out of that. So, but we need to look at what happened after this 2008 recession to figure out what will be the pathway out of this recession as well. So 2012 to 19, when we came out of the recession, the manufacturing, admin, and professional services altogether created about 42% of the job growth in the region. Okay, so the majority of the job growth were recorded for these three sectors. But if you look at COVID's vulnerability sector, that's different sectors. So retail, accommodation, and entertainment. So it's a different sector that's already been affected. This sector, the manufacturing sector, was already struggling to recruit enough skilled people before COVID. So this vulnerability here might present itself as an opportunity if you're able to create a good pathway for it. That pathway will be to take some of these people and reskill them, retrain them to be able to attach themselves to other sectors that are offering jobs. It's not a universal scheme, but it will help to move a large mass of people out of the unemployment. So looking at the pathway to recovery, the Ulster University estimate that it'll take 3 years on a normal upper recovery rate and 4 years on a lower recovery rate. So a good estimate, it'll take 3 to 4 years for us to get out of the economic slump caused by COVID. That gives you a rough idea where we are. So now I'm going to look at 4 examples of how innovation can help companies to embed a bit of resilience in them and to create a bit of stability in their local market. So 4 examples. So the first example is very simple. Self-compacting concrete and fair face concrete. So self-compacting concrete is a global research, started in the 1980s in Japan and then slowly filtrated down. Okay. It eventually came to our companies and our researchers started it and then our companies started it. And it took a long time to diffuse that idea into the industry. Okay. So 2015 is when we estimated as it has completely penetrated the market in our case. So those who understand self-compacting concrete, it's a way the concrete flows around the different complexities within the concrete. So if you have very congested steel reinforcement cage, it can flow around it. It can reach a lot more complicated places. But where it allowed the industry to innovate is what's called fair face concrete, which means they could create molds of different shapes and size, and the combination of self-compacting concrete and the selected minerals gives them the different textures and color and contours that they wanted on the surface. Whether that's an architectural finish, whether that's a feature or a logo embedded, whatever that may be, it gave them that flexibility to create whatever they want on the surface. It gave them the flexibility to insert all the major embedments within the concrete. And that was a big thing. So if you imagine a large concrete wall, electrical conduits, mechanical conduits, any number of other things that needs to be inserted along with reinforcement and whatever insulation, they were able to put everything in, and yet the concrete flowed around it, created a new products range for them. How did that help the industry? 2008 to 2010, when we estimated what it meant to these companies, because they were working with us and we had the figures with them. So just for these 5 companies, there was this much amount of money saved annually for the 2-year period. Now, we have about 45 to 50 companies in this region, so you can imagine what the impact of this would have been, and also global impact for all other companies around the world. But the one thing to remember, this is an academic solution. It took time to integrate, okay? But it gives visibility to all the companies in the region. A good product range can be brought out in whatever shape or size that may be. And you can see some of the products here, okay? They were able to create such a large curvature material and make it here and transport it across. And that feature, the finish and the detail, everything was possible Okay, some of the examples at the bottom are from a company called TechRay. They're based in the Republic of Ireland, but they make architectural facades. It's fantastic products. Okay, so it gives you an idea that they were able to capture the market, enter the market with new products, and enter the market with requirements from architects and able to meet those requirements. So that freedom is what it meant by that innovation for them. The next innovation I'm talking about is a university-based innovation, but it changed a lot of people's lives. So this is called arching action. It's a very simple concept. If you have two beams and a slab is sitting on the two beams, a vertical load on it, a flexural load on it, will be transferred to the two beams through what's called an internal arch. The deeper the slab, the more effective the arch would be. What this means is that without quite heavy flexural reinforcement, this slab will be able to carry the load. That single simple concept meant that people like London Underground, who were using to reevaluate their platforms, were able to keep those platforms alive for a lot longer. And they saved 80 million by the estimate in 2008 alone. Okay, I would have used this arching action in deck slabs in bridges that we assess. So that means if you have corroded reinforcement in the deck slab, and if there are two beams supporting it and there's sufficient thickness, you can use this design manual for roads and bridges, which is a public document, to estimate how much arching action will be there, therefore if reinforcement is required or not. That meant a lot. By 1980, the idea was evolved in 1980s. It was made into a public document in 2002, took 20 years. And then by 2010, it has penetrated the market. It's an academic solution, took a slow rate of integration, but it saves a lot of money worldwide. It's a public document, which means everybody can use it. Okay, so this is the second example. Next thing we looked at is what's called arch bridges. I love arch bridges. They're elegant, they're aesthetically pleasing, they are durable. One of the biggest problems in making them is the need for centering, need for having skilled carpenters to be able to form the centering on which you build your arch, which is absolute pain and a lot of money. So Professor Adrian Long, the person I initially mentioned, he then created a new form in which the arch can be made. Made these voussoirs, basically concrete, precast concrete units of certain trapezoidal shape, and the shape depends on the length and span, and put a polymer reinforcement on the top, and he lifted them. And when you lift them, it forms the arch, and the arch can just sit in place, and once it sits in place, it does not need any reinforcement. Therefore, it's just a compressive stone. Stones and compressive loading has all the benefits of a stone arch. Okay, but the best part, it can be transported to site flat back. So several of these arches can be brought in a big articulated lorry. Okay. The idea was invented in 1994. It took a while before it was rolled out. The first idea, patented in 2004, and it was worked with the company. Macrate is the company who did this work with us. Therefore, the route to innovation, the route to market was a lot faster in this case compared to the previous two examples you've seen. But 85 flexi arch bridges were made since 2006, and £10 million in direct contract, plus a lot of allied work, civil works. Typically, a span of 3 to 18 meters is possible. You can go to 30 meters, but that is a long arch to transport on site. Not really easy to do. You can also create skew arches. The picture that you're seeing is a skew arch being tested. It's possible up to 20 degrees. Okay. But we're talking about what it meant to Macrate financially and project-wise. Flexi arches won about 10 different awards, industrial awards. That gave Macrate the visibility in the GB market. You're a tiny company in a big land of GB, of Great Britain. You need to have that visibility that you're an innovator, you're a creator, you're a new product producer. That visibility meant a lot for Macrate. They were able to sustain themselves during the worst of 2008 to 2015 period. They were able to create new products. They were able to get a lot of allied work. That's what it meant to migrate. So it helped them in a large way. The next innovation we're looking at is what's called modern method of construction. It's a very rapid form of constructing tall, big buildings with a lot of replica within. So Crea Concrete is a company that innovated this idea, and this is nothing to do with the university. It is entirely by the company called Crea. They didn't arrive at this product on their own. They had several products that they rolled out before, which led them to create RapidRes. Okay, they were all their own products. So this is an insulated floor panel or floor slab and precast floor slab. By creating this means you don't lose a lot of heat from underneath your structure. They have these stairs and fully precast stairs that you could buy, whatever length, and they can make it for you, just good finish. And all the self-compacting concrete work as well as the other work meant that they can create these sandwich panels. It has a facade architectural layer, the sandwich insulation that you need, as well as the structural concrete inside with all the electrical conduits and everything else. And they could create these massive panels. So they had already all these facilities, but their biggest problem was they were at the bottom of the chain. They were the suppliers. So supplying industry is very competitive. The profit margins are very low. So Crea then decided we're going to roll out a full solution. Okay, the full solution was we'll make the apartments. And they wanted to make the apartments fast. They don't want to be on site for too long. They are a supplying industry. They don't want to be dragged out into the thing. So they created this system whereby everything just packs on itself. Okay. You can watch a lot of videos online on RapidRes. I'm not spending time watching the videos here. But what it meant to Crea is that it gave them a new pathway, a new product range, things that can be delivered on site really fast. Any sort of facade finish is possible. And they were not just the supplier, they were now the supplier / contractor. So they had a larger share of the pie. They had a larger input into the projects. So they were not forced into the project by others. And the economic side of it is the interesting part. Crea created this product at the worst financial time for them. So if you look at the green figure on the right is their annual turnover. These are public figures. So 2012 onwards to 13, their annual turnover dropped. Okay. And along with that, you could see this blue line is the net profit or loss, and they were making losses. They were sustaining losses from mid-2012 downwards. It is exactly 2012 when they rolled out this product. At that time, they had to lay off a lot of people. They lost a few of their projects, as well as they lost a lot of their staff from 600 to 400. And it was at that very difficult time they decided we need to create something new. And they did. In 2014, they rolled out their first RapidRes. It was a heavy going project for them. But what it meant is they were able to pull themselves out of the losses. They were able to increase their turnover sustainably to a point that their turnover in last year, 2019, is close to £100 million, of which 25% of that is from RapidRes. That's £25 million from RapidRes. They're starting to reinvest in a lot in their product. That's probably why their profits are going down, but that doesn't matter to them. At this stage, they are producing about 400 plus apartments a year in 2019, I think. In 2021, they've committed to produce about 750 apartments in 1 year. There are a couple of things you need to know about that. First, the UK government is very keen to release a lot more housing, both in the affordable housing sector as well as the other housing sector, because there's a housing shortage. They have a target to achieve. That's a very ambitious target of nearly 200,000 houses a year. Crea is doing their part to it. Their innovation is pitched rightly to that market. So And going forward, I think CREA is aiming to produce about 1,000 apartments a year. That's an ambitious target. That'll transform them from whatever the 100 million to 125, 130 million ton company. Okay, that's a big transition. Looking at RapidDress in more detail, what it means is a traditional frame structure would be cheaper. As you can see here, RapidDress would be slightly expensive, but it comes with that perfect finish, the way the finish needs to be looked at by the architects. So it is looking at a slightly bespoke market. But the biggest saving is the program savings. You're able to release things 20 weeks ahead. That's 20 weeks extra of rent coming back. Okay. Your exposure on site is much lower, so you're only there for 16 to 20 weeks in the finishing phase of things. Less accidents, less trouble. You're in, you're out. Your rent and your hire and everything else is low. The product is efficient to the very core of what a traditional frame building can achieve, and that's important as well. Okay, so this is what RapidDress meant to CREA. That's a fourth example. So in the fourth example, you looked at different models of innovation, companies innovating things, universities innovating things, slowly moving to companies, all of them. They all have different paths for economic and social impact. But all of that meant the allied companies were able to create new product ranges, differentiate themselves from their competition, and create resilience in their systems that they can survive one recession to the next. This kind of model is supported by our governmental body called Invest Northern Ireland, which funds the industry in doing research. There are different ways that they fund, from simple innovation vouchers, which is £5,000, all the way to nearly £1 million, but they only fund a certain part of it. They don't fund all of it. So they take innovation from the small seed examples to bigger things. One of the biggest flagship programs called KTP, which is here. It's a partnership where you have the academia, the industry, and the government body coming together to create funding for one research associate, a person, to be embedded in the industry, but trained by the university. And there's a lot of funding stream for that person to be upskilled. And 95% of the time, the company absorbs the associate, and the associate will actually grow up in the company really fast. That's what we have seen. Now, coming back to what this means to our industry with COVID. So for concrete industry, my suggestion is you need to innovate and create new products, differentiate yourself, create resilience in the system. Look at products that are beyond concrete. Also look at timber solutions, steel solutions, aluminum solutions, all to be going in together in one go. Industrial innovation is a lot more faster. That might be the better rate to look at it. Reskilling is extremely important because service sector will be affected a lot more. Train them, bring them over to our sector, which would be great. You will need some form of investments from government as well in this case. That's all from me. Thank you.